Welcome to 7.3 Special Quadrilaterals. This is rhombus, rectangle, and square. So we're going to start with a couple of definitions. A rhombus is a parallelogram with four congruent sides. So it looks like this. It's equilateral. It's not a square, but it could be. So if a parallelogram is a rhombus, then one of the properties is that the diagonals are perpendicular. So what you're looking for is that the diagonals meet and form a right angle. The second property of a rhombus is that the diagonals are also angle bisectors of the pair of opposite angles. So we're saying that 7 and 8 are congruent, 3 and 4 are congruent, 1 and 2 are congruent, 6 and 5 are congruent. Okay, we're going to add this to our flowchart. So on the left side there, we got rhombus. The definition is that it has four congruent sides. The diagonals are perpendicular, 90 degrees. And the diagonals are angle bisectors. So we're going to fill that in. Our next definition is a rectangle. A rectangle has four right angles, right? Equiangular. Again, it doesn't have to be a square to be a rectangle. Okay. So if a parallelogram is a rectangle, then one of the properties is that the diagonals are congruent. So here, AC is congruent to BD. We're going to fill this into the flowchart again. A rectangle has four right angles, and the diagonals are congruent. Now don't forget that the rhombus and a rectangle, they're both types of parallelograms. So they also have all the properties in the parallelogram and in the quadrilateral chart on this flowchart. Okay. Our next definition is a square. A square is a parallelogram with four congruent sides and four right angles. So the idea is that it's both a rhombus and a rectangle. So a square has all of the properties of a rhombus, a rectangle, a parallelogram, and a quadrilateral. But a square has no properties of its own. So when we fill it into the flowchart, square is just simply all of the properties of everything above it. It's rhombus, rectangle, parallelogram, quadrilateral. So let's look at a chart that kind of shows these relationships just on a plane. So the idea is that all of these are quadrilaterals. A rhombus, a square, and a rectangle are all types of parallelograms. But notice that there's other types of parallelograms than just those three, right? They're just simple parallelograms. Okay, a rhombus and a rectangle. Rhombus is four congruent sides, rectangles four right angles. They meet and form a square. So a square is everything in this chart, whereas a rhombus is just a type of parallelogram and a rectangle is just a type of parallelogram. Okay, so let's look at some examples here. Identify the parallelogram. This first one, we have two pairs of consecutive congruent sides, and we have a right angle. And because we have that, we know it's a parallelogram. That means the opposite angles are congruent, and consecutive angles add up to 180, so technically all of the angles are 90. Since they're all 90, it's a rectangle. But since it's a parallelogram, opposite sides are also congruent, so technically all four sides are congruent. So this is in fact a square, because it has both all right angles and all four congruent sides. There we go. The next one, we have four congruent sides, which makes it a rhombus. We do not have right angles, so it's just a rhombus. The next one, what are the measures of the angles in a rhombus? Well, I know that since it's a rhombus, the diagonals are perpendicular, so angle 2 is just 90 degrees. I know that because it's a rhombus, the opposite angles are bisected, so if you have that 50 degree angle, that means angle 3 is 50 degrees. And then angle 1, well, you see that triangle, you can subtract it from 180, you have 50, you have 90, so you get 40 degrees for angle 1. Our next examples, we're going to use algebra here. It just tells us it's a rectangle. We have to draw this picture. JKLM goes around in a circle there. JL is 4x minus 12. JL is one of our diagonals, so let's draw our diagonals in. JL is 4x minus 12. MK is our other diagonal, x. We know that on a rectangle the diagonals are congruent. So 4x minus 12 equals x. Right, subtract 4x from both sides, we get negative 3x. Divide by negative 3, we get x equals 4. But it said what is the length of each diagonal, so we just substitute it back in. Right? You could do 4 times 4 minus 12, or you can just realize that MK is X, so MK is 4 and so is JL. Right? That's all there is to the properties of special parallelograms. Good luck on the practice.